Hello, welcome to the Sharcnet webinar. My name is Ed. I work for Sharcnet out of the University of Guelph, and today we're going to do a presentation on the introduction to SQL on Graham. Now, what we're going to cover here today is, yes, connecting to SQL on Graham, which is important, but it doesn't really make for a whole webinar, so it would probably be better title, Introduction to SQL that happens to be on Graham. So this is going to be an SQL primer, and I'm going to go from the basis of you don't know anything about MySQL. And we're going to introduce the basic commands that can be used as a building block for future webinars on more advanced SQL processes. So the first thing we need to go through will be background information. I'm just going to cover the basics of what a database is, and what MySQL is, and what SQL itself is. So we're going to be dealing with what's called a relational database. And it's just a collection of data that exists on a file on your computer, or in our case, on the Graham server. And it's akin to a filing cabinet. You're going to put data into it, you can take data out of it, and you can manipulate the data while it's there. It is best when dealing with relational databases to kind of visualize them as a collection of tables that consist of rows and columns, much like an Excel spreadsheet that you'll be familiar with. There are things like indexing and keys and such as that that can help you speed up your database. We'll get into a little bit of that today, but these are things that happen behind the scenes that if you're aware of, you can set up your database in certain ways to make them just a bit faster and a bit better. Now, databases, you often hear MySQL databases, but there are a number of different ones. MySQL, or in reality what we're using is MariaDB, which was built to replace MySQL, is a relational database. There's also PostgreSQL, which is a superset of MySQL. It works all the MySQL commands plus a few more. The main differences you're going to see between the different databases that implement SQL is not so much the commands as some of the macros, some of the things that will show you what databases you have and so on and so forth. And you just have to be aware that if you switch from MySQL to a different database, there's also NoSQL, there's also SQLite, that there will be slight differences at times, but the basics are the same. Now, we are using MySQL for a good reason, and that is it is established. It is an old database. It is quite popular. If you've ever done any web programming or using PHP, you've used MySQL in all likelihood, because it's been around for a while, and a lot of people use it still today. So that's why we use MySQL, just for its basic familiarity. I'm not implying that it's the best database solution, it's just the best documented. Now, when I say MySQL, it's what's known as a database management system. And it is the front end on a database that is the back end, from which you access through the language of SQL. And SQL, the language, is what we're going to focus on primarily today. MySQL being the implementation. Oftentimes, you're going to hear these terms interchanged. You're going to hear people say SQL when they mean MySQL, MySQL when they mean SQL. Much the same as when programming, say, Java or C. That's what we're going to be dealing with MySQL. And it is the standard for accessing and manipulating relational databases. Even non-relational databases often have an SQL mapping so that you can still use them because it's such a familiar language. And there is a strong standard for how SQL works, and you can go the MySQL documentation will show you how to use the SQL language. It is fairly easy to switch between database management systems, as they all pretty much use SQL, but they do differ in certain features. So to get started with using a database on Graham, and this also applies to Cedar, you have to first request a database. So I ask that you send a request ticket to support@compcanada.ca. And what we need to know is we need to know what your username is on the CompuCanada systems. We want to know how much database space you need for your project, if you know ahead of time how much it is. And the system you would like the account on, because the databases on Graham are not the same as the databases on Cedar. They are set up the same, but they're not the actual same databases. So we'll create an account for you. It will be given a randomly generated password. And all the necessary information for accessing your database will be stored in a .my.cnf file in your home directory. Once you've got this database, you can go into a login node or a compute node on Graham and access it using the methods I'm going to show you. You also have access to this database through a cloud instance. If you happen to have a cloud instance running on Graham, you can access the Graham database. So the MySQL configuration file, the .my.cnf file, will look something like this. It will have SSL telling it to communicate with encryption. You'll have your username, which will be the same, typically the same as your Graham login name. Your password is randomly generated. It's going to be a series of letters and numbers. The database that you want to load up by default when you log in, you can add that yourself if it's on Graham, or you can specify when you get in. And the host of the database, which in this case is an IP. We do have a proper DNS name. Now, the reason I'm pointing out that this file exists is if you go to a cloud instance and you want to access the database, the information in this file is what you're going to need in order to log in, because it's not automatically included in a cloud instance. You'd have to copy that over yourself. And that's the preliminaries. So that's the basics for how to get access to the cloud. So once you've gotten that, you want to use your cloud. No, that's sorry, not your cloud, your database. So we're going to cover just the basics of creating, using, and deleting databases. So when you get your database, you're actually getting an account on a database server. You can have a number of different databases yourself. And the reason you would have different databases is that the table names have to be unique in a database. If you've got two different applications that both want a database, you'll give them a separate database so that they don't conflict with each other. It's just easier and good practice. So once you've got your account, the first thing you're going to do is log into it, SSH into Graham. We'll do most of our work on a login node, and all of the stuff also applies to compute nodes. After you've logged in, what you're going to do is you're just going to use the command you're just going to type MySQL, and that will give you access to the MySQL database management system, or the server, we'll just call it. If for some reason you don't have a my.cnf file, which you will on Graham and you will on Cedar, but this is just more to be pedantic, you will have to include the host name and your username, and then it's going to ask you for a password, and then you can log in with that. I would recommend in most cases that you can make a .my.cnf file in order to put that information in, because it can get tedious after a while. I've got this included here, certain MySQL implementations. So if you want to access your local files on a MySQL server, you have to specify it. So for security reasons, this is sometimes disabled. We're not as concerned about that because you still have to log into Graham before you even get to the database. So we've allowed you to load local files into your database. So what that means, you can take the data from your home directory and load it into your database, manipulate it, and write it back, which we'll get to near the end of this seminar. But in order to enable it, you have to either include it, that line, has to be included in your .my.cnf file, or you have to put it at the command line. And the first thing we're going to do once we log in to the database is create a database. That's fairly straightforward. And after that, I'm going to show you, you can use a command. So you've got the database, create database, your database name. You're going to use command show databases to show you which databases you've created. And once you've created a database, you need to use a database. So you can only manipulate one database at a time and use the tables within it. And that's the command use MyDatabase, or the name you gave your database. And finally, the last command for manipulating the databases themselves is drop database. And the command is drop database. You'll notice I go uppercase for when it's a command. This is a SQL command, as opposed to variables, which I tend to put lowercase. It doesn't actually matter for most cases, and SQL will accept the commands in upper or lowercase. We do this just to be clear on what's what. Now note, if you go drop database, MyDatabase, your database name, you won't receive a warning. You will lose your database. So use this carefully. I'm now going to go, and we will just access the Graham. So I've already got an account. So I will SSH into Graham. I will be in my home directory. And we're just going to go MySQL. And that will, now we've got a MySQL instance. And we're in there. So if I want to create a database, I'm going to show databases to see what we have. And you'll just get a list of databases that you have. So I've got a dataset, a webinar, and information schema isn't actually a database for you. It is just information on how your MySQL is set up. Now, as a caveat on the Graham system, all the CompuCanada systems, Graham and Cedar, all of your database names have to start with your database underscore the name. And this is just to keep them separate from everyone else. So if I want to create database, it has to be ed underscore, because that's my username, my database. Okay, one row affected. That's in the schema. And we will show databases. Ed dataset test is still there, and now we've got ed my database. If I want to use that database, I will go use ed underscore my database. And now it'll tell you your database has changed. To get rid of it, because we're not going to be using that, we're going to be using webinar, but we'll drop ed underscore my database. And take note, if you get an error, it's sometimes vague messages. It just tells you have an error on that line. Drop database. There, it's gone. No warning, no nothing. And while I'm here, I'm also going to drop. No, I'm not going to drop that webinar because I'm going to use that one. We'll exit for now. So that's how you create, use, and delete databases. It's very straightforward, and you can have pretty much as many as you want, but you'll have one per application. So on to the next. So a database consists of tables. So a database itself is not really the functional part. What's particularly functional and what you're going to be using the databases for is tables. And tables contain the data. So a database is a collection of tables. For our demonstrations today, we're going to stick to one table, just so it doesn't get particularly complex. But a database can have many tables, each with their own unique name. Separate databases, of course, have separate tables. A table is a collection of data entries, sometimes referred to as tuples. You'll see that more in the classroom than you will in documentation. And a tuple is a collection of data. It will not going to the next slide. Oh, there we go. So an entry in a database is the row. If you picture this as like an an Excel table, an entry is a row, and the column represents a collection of the same type of data. So this will be a bit more clear, so we'll go to a table, so this is what's called a schema. And a schema is how a database is laid out. So you've got columns, they all have names. Everything down here will be a name, they'll have the same data type. Everything down here will be an age, a breed, a color, if you have this database of dogs. This, however, is not the entirety of a schema. A schema has a lot of information telling the database both how to behave and what it contains. We are going to primarily focus on what the database contains and a little bit on how it behaves in this webinar. But understand that this is actually a very large subject, so we're not going to touch on everything today. We're hopefully just going to get enough to get you going. Anyways, that being said, the schema not only has the name of the columns, but also the data contents. So in the case of a name, it would be a string. And it's not actually called a string, we'll get to that in a minute, but it means it has text data. You can have number data, you can have multiple different text datas, and multiple different names. The names in a database column have to be unique. You can have the same column name in another database, but all the ones in this particular database should be the same. So you can't have two names and so on and so forth. Now, you should also choose a naming scheme that's consistent in your databases. And this applies to programming and everything, not just SQL. I've, in this case, given them all uppercase. I typically do them all lowercase and separated by underscores. There is a way of naming columns with spaces, which we will get into shortly, but it's advisable not to do that. So that's the schema. The schema is the names and the data values, or the data types. The data name, the data types. Now, like any programming language, there is a multitude of data types in SQL. That's them there. That is a lot. You're not going to use them most of the time. You're going to use just a few. But just be aware that what you'll typically do is you'll choose one for your schema and maybe go modify your schema later on to make it more optimal. But we're not here to optimize your databases. We're just here to set them up. So we're going to focus on a few. These are the particularly important ones you're going to use, which are char for character, var for variable length character string, integer, double, and date. And what they are, and we're just going to quickly go over what the different ones are. So character versus varchar. They're both very similar. They both contain strings, except that a char is represented as a fixed length string up to 255 characters long. A variable char, or a varchar, is a variable length string up to 65,000 characters in length. Now, there's an interesting caveat on varchar in that the total of all your varchars can't be more than 65,000 in the entire database table. And it's just the way it's set up. As far as optimizations goes or speed goes, a char is faster than a varchar in that a varchar is dynamically allocated, but it takes up less space typically. Most people use varchars. Typically that'd be your strength or your char star from C, your string from Java. The next is integer. Integer is your standard whole number type. It's non-decimal. And there are a number of different integers, tiny, small, medium, and big, as well as your base integer. Base integer is the one you'll typically use in most cases. And it's got a maximum signed value, which is by default signed, and a minimum signed value of, what's that? That's in the billions, right? 2 billion. You can also do an unsigned of up to 4 billion. So if you're not too worried about optimizing space, and that's in most cases is going to be good for it. However, a lot of applications are going to want to use decimals. And that is where we get into the double and float. Now, the double and float data types are approximate, and that's fairly typical across most programming languages, C, Java, and SQL. But if you require an exact decimal value, such as you would for currency, it is recommended that you use what's called the decimal data value. And that will represent, instead of using single or double point precision, it's actually going to represent it in a way in which your decimals are accurate. And the last one that typically gets used in a lot of databases is date. And there's a number of different date ones, but the date represents calendar value. There's also time. The typical date one doesn't have the time on it. And there are a number of interpretation rules that MySQL uses for date. However, if you stick to the SQL standard format of year, month, day, you don't have to worry about the interpretation rules. And there are chapters on that in the MySQL documentation. So usually you're just going to try to adopt a certain set of practices that's going to make itself easier for you. So I recommend converting it into the MySQL format before loading your data. But you may not have a choice at times, so let's just be aware that it can be in different formats. So that's the different types of data. You need that data in order to create a table, which is now we're actually going to do a command on MySQL. And it is create table employee. So the create table is the command for what we're going to do. And we're going to create a table called employees. That table of employees is going to have the schema with 3 columns named name, ID, and start, with the column data types of varchar, int, and date. So it's fairly straightforward. It's just an example table. It's a nice, easy one to type up. But now we'll show you how this will SSH. We're already in Graham. So MySQL to enter. I am already using the database, but we would use ed_webinar. Now the problem, as is often the case in learning things like this, is I'm going to be using commands that I may not have introduced yet. So just be aware that I am going to show you what show tables is and drop table employees, since I've made it before. So show tables is just going to show me what tables I've made. So I'm going to go create table employees. Noting that I did the create table in lowercase here, it doesn't actually matter. The new lines are remembered by MySQL, and all commands have to end in a semicolon. We put it on a new line just so it's a bit easier to see when I'm typing it out here, but you can put it all on one line. And start date. Close the parentheses, semicolon to finish, enter. Query OK, 0 rows affected. Now we're going to show tables. And now we've got a table, employees. If we want to see what else is going on, so we want to see how we built that, we are going to use a command called describe table employees. And it's going to, describe employees. And it's going to show us what we just did that built the table. So this is the schema here. And there's more information here than what I've introduced. There's, for example, whether or not you're allowed to have a null value, whether or not it's a key, default values, and extra. But we don't care about that right now. We care about field, which is the field name, and the type, which is the data type contained in that field, which is varchar, int, and date that I introduced earlier. So now we've got a table, and now you've seen how to start it and how to see what it is. How do we get data into it? So this is just going to be a little preview, and we're going to visit this very briefly for entering and retrieving data. So we're going to get more into it in a bit, but like I said, we have to bounce back and forth a little bit just to understand other things. So to get data into a table, the simplest way is with the insert into employees, the table name, values, and in a list, the same order that I created the table, you've got the name, the ID, and the date. And that's just a bit of a preview, so you can see what's going on. To get data out of the table, you're going to select star from employees or to retrieve all of your data. So we'll just show you that real quick. So insert into employees. You can sometimes tab finish that. Values. I'm going to put this all in one line. Now note, I am using the single quote for the names. The MySQL itself doesn't care, but the standard is single, so just get into the habit of doing that in case you switch to a different database. Note that dates are also quoted. So there you go. That should insert one row affected. Query is OK, so that means one row has been changed or touched in some way. And we'll see what we've put into it. So we're going to go select star from employees. And now it will just show us everything's in the table, and there's only one thing in the table now. So moving on. So now we're going to bounce back to create table. As an aside, if I wanted an unsigned character, or an unsigned integer, there's a command you would put it in when you create the table and just add it after int. So int ID, int unsigned. And there are a large number of these that you'll experience as you use MySQL. But this is just a simple one that everyone's going to understand. That just means there are no negative numbers. So now we go from 0 to 4 billion instead of negative 2 billion to positive 2 billion. So at times you'll see other things there like not null and auto increment, which we'll get into shortly. Reserved keywords and spaces. Now this is what I was mentioning when designing your schema. You want to choose some naming convention that makes sense. And if you've used other programming languages, you probably already have one in mind, such as camel case or Pascal case, stuff like that. You can use spaces in the table name, even though you shouldn't, as here it's shown, and that's because it's being quoted in the table name. You can also, sometimes you'll run into issues where I'll say index int. Index is a reserved word for SQL. Create is a reserved word, table. There's a number of reserved words. If you insist on using a reserved word, usually because the data was provided to you from somewhere else, you have to put it in quotes. Now you may note that these are slightly different looking quotes and that they're not typical. In order to do this, you need to use a backtick. So as opposed to the double quote or the single quote that we use most of the time, when we're doing this using reserved keywords or adding spaces for the column name, we're using a backtick. That can be confusing when you read these because they don't necessarily say what kind of quote it is. Single quotes should be used for string values in your values list when you're creating the table or when you're inserting data. Double quotes, like I said, are supported by MySQL for strings, but single quotes are more widely accepted by other databases. And then to say again, or to repeat myself, I suppose, MySQL expects date and date time and literals like that to be quoted as well with a single or double quote. So now that we've gone through that, we've bounced around a little bit, we're going to now focus a bit better on inserting data into the table. So we've seen this one already, where we inserted a single row into the table of employees. And with values we specified insert into employees. I didn't show you before, you didn't see the name, ID, and start. And what that is doing is, it is specifying which columns we want the values to line up with. You don't have to include that if you've got data that has all of the same columns, or sort of matches up in the same columns in the same order. If, say, you want to omit one, then you'll have to specify what columns you're doing. we will format it a lot of the times like this as a way of demonstrating what's going on. But you'll note when you're in MySQL and you can arrow back to see your previous commands, it's going to put them on one line. So if I arrow up here, I can see insert employees values. So it's all one line. When I created the table, it was multiple lines. Now it's all on one line. And that can get single line commands can be difficult to read sometimes. And you'll see when we use files later on to insert commands that this format is a lot easier to read. So we're going to insert some different data points into our database now, just as a demonstration. So we've already got Adam. We're going to add Adam again because it doesn't have to be unique. We've not set any rules for that. So we will insert into employees. I'm going to go name, ID, and start. Those are the names of the columns that I'm inserting into. Values, the value list. We're going to add Adam again. We'll put 2 and some date. And we'll select, we'll take a look at what we've done. So now we've got 2 Adams in there with slightly different values. Say we wanted to enter it without the ID. We would take out the ID value. We would omit the actual value. So we've omitted both the column name and the value. And now, when we select all from employees, you'll notice a null value where ID is. And that just means it was never input. It is now, it is not 0. It is not a number. It was never supplied. You can also change the order of your columns. And this isn't particularly important if you're doing it by hand in the console. But depending on where your data comes from, you may, and you automate or you make scripts that do this for you, you might want to be aware that the data does not have to be in a specific order. So now if we select from employees, we'll notice that even though it's in this order in the database, it doesn't have to be inserted that way. And so on and so forth. And I'm sure we get that now. And of course, to reiterate again, if you include all of the column names, they will be by default in the order that you provide. Now this should throw an error. And the reason for that is the index is out of order from the date. So we have to put that back to where we actually want it. Now, it seems a little tedious to enter the data one at a time like that. And if you're creating a script, it doesn't seem to work very well with a loop. You can, however, insert multiple sets of values at the same time. So what we'll see here is you insert into employees the column names, the same as we did before with a single value, and then a comma-separated list of values, all in their own set of parentheses. And when you enter this in, so we will add them in there again. Comma. And you notice I sometimes switch back and forth between the types of quotes. I try to use the single quotes as we do, but I've got such a habit of using the double quotes. And that actually causes problems, which I will show you briefly. So there we go. 2 rows affected, 2 duplicates. That means we've doubled up on something. And that means we've entered 2 rows into it. That's what we care about there, is the 2 rows affected part. Select star from employees. We've now got both of those data points, so we just entered. Now it's all fine and dandy to enter the data, but now we need to retrieve the data from the database. And these are, you're going to spend a lot more time around queries, which is what these are called, than you will inputting the data. And a lot more optimizations happen around these, which of course we won't get into today. But it is the basic way of doing this, of selecting data, select star from employees. So select everything from your database, which is not typically what you want to do. And we'll see how to refine that in a minute. But let's just break down what's going on here. So select and from are SQL keywords. And you see that we've capitalized that just to make it clear. And you're familiar with that from when we created the table earlier. But also, these two things, employees, the table name, the table selector, and the star. Now you've seen the table name before, but the star means all. It means select all columns from that table. And that's what was going on to see what the data was that we input. However, we don't necessarily want everything. Oftentimes we want to know just the names from the table that we've input. So select name from employees, or name and ID from employees, or maybe we want them all again. This is the same as saying select star, name, ID, and start. We can also select that as a different order. And this happens if you're outputting your table to a data file, or you need to send it to a different program. You can change the order of your column names. So we'll just go a quick little demonstration of that on the terminal. So we will select name from employees. So those are all the names that we've entered. If we've entered it multiple times, it's going to show up multiple times. Select name, comma, ID. We get the ID and the name. If you want the ID name, then ID again, you can do that as well. And you'll see here, it'll tell you how many rows are in the set. And that's just so you know how many match the criteria. There's not a lot of criteria going on right now because we're selecting everything. But that's what it means. Now, the problem with using or switching around quotes is you sometimes get yourself into a little bind on the command line. So if I go and I want to insert into the employees, and I've done AD and I hit enter by mistake, you'll notice that there's a little quote thing here. And I want to change my mind, I hit enter, it's just going to keep entering there. You'll want to close your quotes off before you can do anything else. So if we did that, and we hit enter, and we try to close the command with a semicolon, and now it takes it to quote. We have to close it, and then close the semicolon. Say we were doing something and we shouldn't just hit a semicolon like that. You may want to terminate your command. You've changed, you've hit enter, you don't know what you've done, you've made a mistake. /C will terminate what you're doing and just ignore everything else you've typed. If you've typed a quote of some sort, and it shows up here, here's a single quote, you can close the quote, hit /C, and it will terminate what you're doing. If you do it /C inside a quote, it'll treat it as a string. And that's just something that's handy to know for when you type something wrong, which you do constantly. So that's just a bit of an aside. So to move on with selecting. Selecting rows by content, which means you don't necessarily, may want to show all the columns, but you don't want to show all the rows because you'll have tens of thousands of entries at times. And you want to select specific things. You want to query your database. This is what they're for. This is the purpose of a database, is to look for specific things. So we're going to introduce the command where. Select start from employees. So we're selecting all columns as we did from before. But we're going to specify what columns we want. And this is where columns match. Where the column ID matches the value 3. So select star from as I don't have a 3 in there, so we'll do something else. Where ID equals 1. So you get the 1. You can also do where name equals Adam, so you can check for strings as well. And in this case, we should get back multiples. Oh, not where ID equals Adam, where name equals Adam. And we get all the ones that we entered that were Adam. Now you may notice something there, that if I go select star from employees where name equals Adam in upper cases, you're going to get it is not case sensitive when it comes to strings. And this is a bit unintuitive at times. So when we selected Adam there, we go Adam, all capitals, we get the same result. So just be aware of that. Now there is a way around it, and that is with putting the binary command in front of it. And that means it will specify, it will pick only the exact string that you want. And there's a couple of other ways of doing it. That's the most straightforward way of getting around the case sensitivity issue. Other things you might want to select. So say you want to select specifically everything starting with A. So we're going to have to insert, I'm going to insert a different employee in here. And now we've got another one, so we're going to select all employees with the name that starts with A. So we're going to select from employees where name equals, in this case, a %. So the wildcard character in SQL is %. Oftentimes you'll remember it as, why didn't that work? It's always the case. There's always something. There we go. Like. So in order to do the string comparison with the wildcard, you use the keyword like in there. So there we get all of the ones that start with A as opposed to exactly. And I'll edit that slide later. And of course we saw the binary, so if you need specifically upper lowercase. Now you can also select multiple rows, right, or multiple criteria. And the simplest way of doing that is with the also familiar AND. So you'll select where name like A and ID equals 1. We're only going to get the Adam 1, or Arnold, not Arnold 12 or Adam, the other Adams. So let's insert a different name into here. And we're going to use the same ID that we have used already. There's no rule in there that says they have to be unique. And in this case, we still get the Adam because it's name Adam, or name starting with A, and ID equals 1. However, you can also do name starting with A or ID equals 1, in which case you get Cindy as well because her ID equals 1. And of course, to be pedantic, if we put in a name that does not start with A and does not have an ID of equal to 1, you won't get that back. And there are other qualifications. There are other things you can do to select and to add to your where clause in order to select specific types. But those are your basics and how to string them together. So, but we need to move on from select into update. So we want to change existing data, and the command we're going to use is update, and what's going to be the update command, your table name, the set command, so it's going to set the column name to the value you want, where you've got some qualifying information. So it'll select all rows that qualify with your where clause and change the value. So as a quick demonstration, update table name, employees, set name equals Chris, where name equals Adam. And this should change all of them. So if you select star from employees now, you'll notice all of the items have changed to Chris. And you'll also note there was no warning. So what you'll want to do when manipulating your data in a working database is use your select clause first in order to see what data is going to get changed, and then do your update, just to make sure you've got it right. Now, using update, you don't have to change the value of the column that you selected in your where clause. So if you want to change specific start dates, change the ID for them, you would just, we are going to update employees. We're going to set start equals some date, be different, where ID equals 1. 2 rows changed. The reason 2 rows have changed is because we have got 2 IDs equal to 1. And now they both, where 1 was null before, it's 2016. Where it was 2018 before, it's 2016 now. So it will update multiple rows depending on how many it finds. Also, if you want to check for null, you don't use equals null, you use the keyword is. So you'll where start is null, so where we haven't provided a value, it will set a value in that case. Note there is no undo in MySQL, so when doing these things, particularly as we move on to delete, you want to be careful about what you've done or what you're doing to your database. So the first thing, moving on, removing data. So you say we've added database to our table that we now want to take out. We need to use the delete keyword. So delete from your table name, employees, and our where clause. We're going to see a lot of where clauses. In this case, we're going to remove all of the Chris's as there are multiples in there. And now they're all gone. No undo. Note, you can also where start is equal to end. So you can say, if I had a table that had 2 different columns, a start and an end, you can compare columns to it, which I didn't actually set up a table for this. Or, moving on from that, you can also delete everything from a table. So in order to empty your table, delete with nothing from employees, and that will empty your table out. Use sparingly. I use it a lot during the demonstration, but you won't use it too much in day-to-day uses. Pushing on, executing SQL files from source. Now this is the way you're typically going to run things, particularly on the cluster, where they're not necessarily running live or interactively, and you want to run it as a job because some of these queries will take a while. What you will do is on the command line, you will pipe in your SQL file. So here we've got the MySQL command. You put in your flags in between that, and your input would be the instructions in a file, which I typically just call .sql. And it's a plain text file. If you want to see what you've typed in, so you want to see the command that you've given on the command line or into your output file, you'll use the command verbose, -v, verbose or -v works as well. -vv means very verbose, and it gives you even more information. If you want to enter a command from the command line, so not in the MySQL program, use the -e flag and then put your command in quotes. And that will do the MySQL command from your bash command line. And while you're in MySQL, so these ones up here, note, are from bash, and this one down here is while you're in MySQL. You can actually use the command line source, the instructions that you've given. Now, when you do this, you're going to want to make sure that your instructions are in the same directory from which you instigated, or relative to where you started up MySQL. So, exit. I am in my home directory. I've got a directory MySQL webinar with some files prepared. So, if I want to say set up a table, so I've got setup table 1.sql. So this is a slightly different table than we had going before. The first thing we're going to do is, you'll notice, drop table. So that's going to delete the table that we have, employees. It will cause an error if it doesn't exist, so we've added the phrase if exists. So this will delete the table if it exists. If it doesn't exist, it does nothing. And then the exact same thing that we saw working on the MySQL command line, you see the first name as the column name, and then the column type, and so on and so forth. And this is just a file. And to run it, we will go MySQL, type in the commands, which is setup table 1.sql, and now it's done. Now you don't see any output. You'll have to go into MySQL to see it. Select star from employees. It should be empty because we dropped it. And describe employees. And you'll notice it's different than we did before because we just reset it on the command line. To see if we use the -- for both command, or the -v flag, it will show you the commands that you did. -vv if there's more stuff to know, which will show you whether or not the queries were successful. And that's the same thing you see when you're in the actual MySQL program. We will insert data into the table through this with insert. Insert data, SQL. So here we go. And these are the commands that are in the file, insert data. So we literally just go with the values and then your comma-separated list of values. This is where that becomes important. Into the table that we create up here. So we drop the table, create the table. So now it's an empty table. And if it didn't exist, it does now. And now we're going to insert a bunch of values into it. Now, instead of logging into MySQL to see it, we might want to see everything that's in it. So we're going to use the -e flag. Select star from employees. In quotes. Oh, semicolon. And don't forget the MySQL command. Let's get that right. There we go. So now it's going to output the file to the console. Now, at times, you may want to capture this information, but you may not want the pretty output that's being provided with it. And we're going to use the -s for silent. And then the first -s gets rid of all of the lines, and the second -s gets rid of the headers. So you'll notice the difference between up here, so you have the column names, and down here you have only the data. So silent twice, -ss. And then you can pipe that into a file, and you can use that for re-inputting data, which is what we're going to go to now. And this is probably something that you don't necessarily run into on a web server or if you're just recording stuff, but a lot of times you're going to want to input data and do something with it on the MySQL database. And the command we're going to use is load data local. Now, you don't always need the local command. Well, you will, but if you set up your own data, say on a cloud instance, if you don't include the local, then it works as the server loading it instead of the client loading it. It's a small distinction that makes it a little bit faster, but a little less secure. The clusters are more secure on the way you log in, so thus you input your data to the local. So it's load data, local, means from your directory, not from the server directory, in file, the file name you want to load, into table, the table name you're going to load it into. Now, the format of this file is going to be the same as that output select command by default. However, it doesn't have to be. You can change the values on the delimiters by adding the fields or lines command. However, when putting these, the clauses are optional, but fields must precede lines if it's specified. So if you have a fields, it has to be first if you also have a lines. Also take note that there's string literals here, which means they're enclosed by quotations. So the file name is enclosed by quotations, and so are the delimiters. So in this case, the fields, it's tab delimited file, which means each column in a row is separated by a tab. They are not enclosed by anything. And if you have an escape character, it's a backslash. There's a double backslash, so it has to be an escape character. Lines are terminated by /n, which means new line. In some cases in Windows, you might want to make that a /r/n, character return new line, depending on how the data was exported. And then you can always have a starting line. So if you've got a file with some other data, you can put a specifying character that starts the line. However, we really prefer, or you should prefer, to use the default value. So if you see here, employees data.tab, I use tab to specify tabular delimited file. We've got a file with just data. There's no quotes around the strings in this case because it's a data file, not SQL command. We are going to, in MySQL, load data in local, because it's coming from my directory, not the server directory, in file, employee data.tab, into table employees. Select star from employees, and voila, our data is in it, as it was in the file. If, however, we have comma separated values, which is a very common format, so it was same data, but comma separated values, we're going to want to specify the delimiter as commas. So back in MySQL, we will load data employee.csv into table employees, fields terminated by comma. Select star from employees, and now we've loaded the comma delimited file in as opposed to the tabular delimited file. Moving back to the slides, that's what we just did there. As I'm running out of time, I'm going to just make a quick mention of these commands, the create table and the load data local in file command can also be included in an SQL script. So here I've got a variety of SQL scripts in load data tab 1.sql. It's just the load data in file. And this is the kind of thing that you would pass into a batch command. So I've got a submit.shell here that I would use with an sbatch. And this is how you would submit the job to the cluster. And it's very straightforward. So it's the same as any other job you've submitted. In here, we've got the particular slurm commands. MySQL pipe in the file that you want to use. So we set up the table, we load the data, and notice we want some output. Now the output's going to be going to sbatch.result.text. We use the minus VV to make it to make it output everything, and the command select star from employees. So if it's only one line, we can just make it a execute command. And I've already done this, so sbatch result.text, and this is what we got from running it. And you'll do that for more complex queries. And of course, to save the data is, if you've got a table and you want to save the data, send it somewhere, the easiest way to do that is from the command line with MySQL -silent twice, execute a command, select star from employees, and we'll output it to data.tab. Employees, not employees. And now the data.tab, of course, is the tab delimitated file, which you can then add back in to your database. And that is one way of backing up the information in your database.